Okay, so thanks for joining us today. My name is Jim Vajda. I'm the Chief Wireless Officer here at 7Signal. I do a lot of other things as well. Tinker and play around and with ham radio a lot. And recently I've been playing with DMR radios and experimenting with that. So if any hams out there have any talk groups I should check out, drop them in the chat. But today, I want to make the case that we should stop saying data rate. Okay, now this is a little tongue-in-cheek, but I want you to start thinking differently about data rates at least, and let's add this to our list of Wi-Fi bad words, right? So maybe the first one that's kind of a bad word in Wi-Fi these days. Single channel architecture. We're probably not doing that anymore. It's hard for me to come up with a good use case for a single channel architecture Wi-Fi design today. Maybe that was different over a decade ago, but these days, just don't do that. That's a bad word. More recently, the word site survey, the term site survey has become a bad word. We've heard friend of 7Signal, Keith Parsons, and Sam Clements start saying, don't say site survey. That's a bad word. And that one actually threw me for a loop a little bit because I thought, well, what do you mean? This is part of the job. Site surveys are something that we do a lot, and they're required to have a good wireless design. Problem is the term is poorly defined and it means a lot of different things to a lot of different people. So it's not that we stop doing site surveys, it's just that we get more precise. And instead of telling, a customer, I'm going to do a site survey, we tell them, I'm going to troubleshoot and fix your Wi-Fi problem, or I'm going to do predictive modeling, or I'm going to validate the design. And we're clear about our intentions, because what a site survey literally is, it's just going around and taking measurements, and you end up with a nice map showing RF measurements and heat mapping and so forth, and that's it. Well, most of the time when people ask for a site survey, what they really want is you to take that data and do something with it. So that's what we should specify when we're talking about when we use the word site survey. But today I'm going to make the case that data rate gets on our list of Wi-Fi bad words, and what we should normally be talking about is MCS. And I'll make that case today. So first, let's talk about modulation in Wi-Fi and how important it is. This is a visual representation of the complexity of a couple different modulation types. There's more than this. There's further to the left, there's BPSK, and further to the right, there's 1024 QAM. But this is a good way to sort of understand their complexity. It's not what they actually look like. What we're describing here are radio waves. But this is a way to show, how many different values a single waveform can represent using these different modulation types. So on the left, QPSK, there are 4 values we can get from that modulation type. And on the right, with 256 QAM, there are 256 different values. So that means we can encode a lot more data using 256 QAM. But it also means that the difference between those values in 256 QAM are much, much smaller in terms of the physical difference of the radio wave. So we need a lot more precision for the receiving station to be able to demodulate it and decode it. So that means we need a nice high RSSI signal with low noise, without interference. We need a lot of SNR for 256 QAM to be received. So while it's able to support much higher throughput, it has higher requirements. If we look at QPSK, because those values there's so much space between them, it doesn't need as much SNR. It can tolerate some noise and some interference, and the receiving station can still figure out, oh, well, I kind of hear this value. I'm just going to say it's that value, and more than likely it'll be right. The margin for error is much greater, or there's a much larger acceptable error margin here, where we'll still be able to demodulate QPSK properly. And so what happens is, like we learned in the poll, a lot of us learned, the transmitting station chooses between these modulation types on its own, based on its own sort of data rate shifting algorithm in determining, what rate and what modulation is going to work, depending on, how successful it's been with recently using different modulations, and what its bit error rate has been, and so forth. But in general, the transmitter is using QPSK and BPSK because the link quality is poor. The RF environment is not great. And it's using 256 QAM and 1024 QAM when the RF environment is really nice and we have nice loud signals. So let's kind of, look back in time a little bit at some older generations of Wi-Fi, where we can see how the different types of modulations worked with the different data rates, and how few data rates we had. So with 802.11b, we really just had, the first popular form of Wi-Fi, we just had 4 data rates to work with. And the higher data rates had used a differential QPSK, and the lowest data rate used a differential BPSK. The difference between differential and non-differential isn't really important for what we're talking about today, but we kind of started thinking about we started using data rates to talk about link quality, because for the longest time you could see that in general, as data rates went up, that was because of modulation changes. And you can see that same trend with 802.11a and G, which introduced the same OFDM data rates and 2.4 and 5 gigahertz respectively. And of course, the lowest data rates there are BPSK data rates. The highest are 64 QAM. So these things were nicely linked. And then, with 802.11n and AC, things got a little bit more complicated. But if we looked within a single set of data rates for a channel width and spatial stream combination, we have the same sort of coupling between modulation and data rates. So for a long time, we kind of look at the data rate and say, oh, okay, well, the data rate's high. That's nice and high. That means we have a very healthy connection. This is a good quality link that's supporting a high data rate. And that tracked very well with the MCS index, which came to us in 802.11n. And we've had it ever since then. So, we kind of formed a habit of looking at data rates. And we got this new thing new to Wi-Fi at least, the MCS index. And for the most part, we could just keep talking about data rates without much concern, because you can see these things are pretty closely linked. And MCS feels a little abstract and unintuitive, just the single integer. And what does that tell me, right? I just want to tell me the data rate, because that's going to tell me how much throughput I can achieve, for example. Although I think that's a misunderstanding, because throughput is really also determined by channel availability. Can we transmit every time we want to transmit? And there's also a problem at the very bottom of the data rate chart, in that we can only go so low. And if we get all the way down, like on the left with 20 megahertz in one spatial stream and 802.11 AC, if we get all the way down to 7.2 megabits per second, the rule of thumb is about half that we could use for real throughput. But in the real world, we're not going to get 3 or 4 megabits per second when we're using that data rate. We probably have channel conditions that support a much, much lower data rate. It's just that the transmitter can't shift any further down. But that's a side note. But all the way through 802.11 AC, we've looked at and interpreted data rates as a way of understanding the quality of the wireless connection. So when we get to 802.11ax and we look at all the data rates that are available, this is just the 3 spatial stream data rates, up to 3 spatial streams. With 4 spatial streams, and there's plenty of 4 spatial streams APs out there, there are 1,440 available data rates, which is just a ton. And we'll never be able to memorize these like we used to do with with the previous PHYs. And not only are there so many, but they're all brand new. Like 802.11 AC, it really added data rates on top of what we had with 802.11n. 802.11ax is all brand new data rates that aren't shared with previous PHYs, because the subcarrier utilization is different and so forth. So can we do the same thing? Can we just look at the data rate and make the same inferences that we used to? And I'm going to show you that unfortunately we can't. So gonna do a little and thank you, Yermund, for playing along in the comments here in the chat. So just a little interesting exercise. Look at a couple sets of data rates and figure out what the MCS values might be for each one. So they're all kind of a group of 802.11ax data rates that share the same channel width, spatial stream, and guard interval combination. So if you looked at that group on the left, we've got 4 different data rates. One's pretty high, one's pretty low. So we expect to see the MCS values reflect that, right? Be the same sort of, I don't know, 8 or 9 since we're just one spatial stream, maybe less, and then something pretty low at the bottom. But they're not. So the MCS index here for every single one of these data rates is 11. Well, how could that be? Okay, well, let's look at the next set. Here again, we see another list of data rates and ordered highest from lowest. And this, same combination of operating conditions as the first list. And turns out these all share the same MCS value as well. right? So MCS 7. Well, how could that be? We you know, the rate on the bottom, 8.8, is like 10% of the speed is the data rate on top, 86 megabits per second. So how is it possible they're all MCS 7? And if we go out to 40 megahertz with 2 spatial streams, which is a pretty common combination we'd see in 802.11ax, we have even bigger discrepancy just within the MCS value of 4. 10 megabits per second, it has an MCS index of 4, and so does 206. So starting with 802.11ax, data rates appear to be decoupled from changes in modulation, like the MCS index would indicate for us. And so I think that's why we need to rethink and stop using data rates for some of the old purposes we use them for, particularly around reliably tracking link quality. So what's the problem? Yerman already knows the answer, but don't spoil it, please, Yerman. So the problem, if we look at this and we zoom into one row of 802.11ax data rates, MCS 11, like we saw in that first group of data rates, the problem comes from OFDMA. And what's happening is that as OFDMA is occurring and the AP scheduler is assigning different resource unit sizes to a station, that changing in RF bandwidth affects the resulting data rate. So that's why you could have MCS 11 with 1,000, over a gigabit per second phi rate, but also all the way down to 14 megabits per second, depending on the RU assignment and the channel width. That the 26 tone RU is only 2 megahertz wide, right? So the station with 1,000 megabits of data rate is able to use a whole 160 megahertz wide channel. But the station that's temporarily, the same station at 14.7 megabits per second only gets to use 2 megahertz when it transmits. But the important thing here is the modulation is still 1024 QAM. We still have a really high quality link if we're able to maintain 1024 QAM, a really high quality link. I want to emphasize that 1024 QAM is not easy to pull off. So we can't look at the data rate and say, oh boy, something's wrong here. Actually, it might be perfectly fine. So let's just kind of put a finer point on what OFDMA is doing. If you look at the left, that's how Wi-Fi is operated for its entire history up until 802.11ax in terms of how the channel is shared. It's only shared across time, frequency domain. When a station wins channel access, it gets the whole channel. And so you can see those color-coded users. Those are Wi-Fi stations. And we'll just look at user 0, the blue user. When user 0 wins channel access with OFDM, it transmits across the full, we'll say 20 megahertz. Say this is 20 megahertz channel. It always gets the full 20 megahertz. That's how Wi-Fi just always worked. But with OFDMA, which is what can occur with 802.11ax, it's important to understand that 802.11ax will do single user operation, which is what you see on the OFDM side rather, and multi-user operation, which OFDMA is. When it's doing OFDMA, Then we're also dividing that 20 megahertz channel up into smaller resource units. So our user 0, our blue user, started with half the channel. It only had 10 megahertz to work with. Then it got like a quarter of the channel, 4 or 5 megahertz, and then back to the full 20 megahertz, and so on. And as the available channel bandwidth increases and decreases, that alters the data rate that the station can transmit with. And when that happens, and that happens, I should say, it can happen independently of changes in modulation. So that's where we need to rethink data rate and stop using it in certain contexts, particularly when we're talking about link quality, for example. So I've told you we should talk about MCS, and I'm going to dive into MCS here. And, I think MCS tells you what you really want to know most of the time. Now, you might say, well, if I just want to know how good my Wi-Fi connection is, why don't I just look at the signal strength? Why don't I just look at the SNR? And I wish we could. That would be a lot simpler, because SNR at the end of the day is really what we're after. The problem is the SNR measurements we get from Wi-Fi clients and APs are not, they're not, I don't want to say they're not standardized, but I guess they're really just not standardized. They're interpreted values. They vary enormously between different chipsets and devices. And even the very same make and model device, if you compare a group of them, might show you totally different RSSI values. Really cool website, rssicompared.com, where you can see some of that. So measuring signal strength isn't a reliable thing, unfortunately, that Wi-Fi clients do. And they're even worse at measuring the noise floor. They really can't measure the noise floor the way that in the way that we understand that the term noise floor to mean, like what a spectrum analyzer would see as the noise floor. The numbers you get from most Wi-Fi chipsets are pretty poor and easy to misinterpret it. And that's a big rabbit hole I'm not going to go down, but I would say if you're not familiar with how a Wi-Fi chipset is specifically generating its noise value, it's junk, and you should just ignore it. So if we don't have those, well, we can still use MCS to infer the quality of the link, right? Because as we've learned, the transmitting station is shifting its MCS, its modulation encoding, in response to different, to the channel conditions it's dealing with. And it uses the highest in general. It wants to use the higher order modulations, so it can get across. It can send its traffic faster and consume less airtime. So it's almost as if clients are sort of doing an RF or a Wi-Fi connection health check when they're going through their rate shifting and landing on an MCS to use. And MCS is standards based, like I mentioned. We've had it since 802.11n, and it's you can pull it from devices or over the air from packet captures, and it MCS rates do track with link quality, no matter what the resulting data rate is. That's where I want to get across here. So that's why we should use it. Just to review, if you're still scratching your head about what the MCS index even is, It's extremely simple. It is unintuitive and sort of seems abstract at first. Like, what's this? Just a 0 or an 11, or what's that mean? What does that tell me? It's just a simple way, and I zoomed into a crop of the MCS index here, and you can see the whole thing at mcsindex.com. Really good site to bookmark. But it just tells you what combination of modulation and coding you're using. So we already discussed modulation. And actually, if you want to learn more about modulation, I'm going to put a link in the chat here from a excellent kind of whiteboard learning video Keith Parsons did on modulation. I actually go back and watch that periodically just to relearn that really good lesson. So thank you, Keith, for that resource. But we already learned about modulation. Coding is very simple. It just talks about it just describes how many bits that are being modulated are used for data versus how many are used for error correction that are a little bit redundant, so that the transmitter can tell, or the receiver rather can tell, if it's getting if there are errors and potentially correct them without having to do any retransmissions. So different coding rate or coding schemes actually get a little bit more aggressive. Fewer bits are used for error correction the higher up they go. But the big thing to pay attention to is the changes in modulation, because as we saw, it's a big deal, right? To go from 16 QAM to 64 QAM, the margin for errors is much different there. And MCS is also not unique to Wi-Fi. If you want to go Google 3GPP LTE MCS index, you'll see a huge table of cellular data rates and their corresponding MCS values. So it's a useful way of thinking about link quality and the important part, what you really want to know about the connection, right? So how do we interpret MCS values? There's just like the way we used to think about data rates, different applications have different needs, and the same is true for MCS. But I am going to suggest, a starting point. And I'm going to, now we're really going to get technical, guys, and I'm going to summarize these and with some highly technical emojis. Okay. So first things first, if you're at 64 QAM or better, things are pretty rosy, right? That's a fairly complex modulation scheme, needs a good amount of SNR, and that's indicating the client's feeling pretty good about the RF conditions it's dealing with. So we're doing pretty good. It really should be easily achievable with modern chipsets too. Every new generation of chipset, is a little bit better than the last, and can operate at higher order modulations with a little bit less SNR than the previous generations were able to do. So 64 QAM or better is a good indicator of a healthy link. 16 QAM, MCS values 3 and 4, we're starting to get a little nervous. So this is again, it's just kind of a generalized starting point, but this is where, modern, like I mentioned, a modern chipset shouldn't really be shifting down this low unless it's really encountering something, some sort of degradation in link quality. And this is in my experience, this is probably not perceivable to the end user, right? We're still going to be streaming video and doing Zoom calls and things like that. It might be just fine. But for the wireless engineer, if you've got a lot of clients that are hovering around MCS 3 and 4, you're kind of sitting on a time bomb that is going to go off when the capacity starts to get challenged of the network. If a lot of clients are if you've got a high density network, like most networks are these days, and a lot of clients show up and they're only able to achieve MCS 3 or 4, that's going to really dampen the total capacity of the network. So that's something to think about. And then if we're down at QPSK and BPSK, MCS 0 through 2, something's wrong, right? We're using modulation schemes that have been in Wi-Fi for over 20 years. And if a modern chipset can't do any better than that, it's because it's really suffering and it's just trying to get any bits at all across the link. And like I mentioned before, MCS 0 especially is a big warning sign. Don't be fooled by that MCS 0 data rate. That's a mirage. A client that's at MCS 0 or an AP that's at MCS 0, it's probably there because it can't go to MCS -5 like it should be, right? That's the absolute floor and it can't go any lower. So that's especially a bad sign, right? When you're at MCS 0, the real throughput sometimes might only be in the kilobits per second, or it may, for significant periods of time, be 0 bits per second, right? It's just the absolute bottom it can go, and it can't shift into rates that like an IoT device might be able to use with the different protocol. So that's just something to think about. Okay, so just to summarize, Wi-Fi bad words. Today, we're the language police. We're not doing SCA anymore. By the way, if you're doing SCA, if you've got a good use case for SCA, put it in the chat. Maybe there's a good place for it still in enterprise Wi-Fi today. Site survey. Yep. We just need to be more precise, more specific about what we're doing. And by the way, all these things on the right are a lot more valuable than just walking around and taking measurements like what a site survey actually is. You can train anybody to do a site survey, but the stuff on the right is where you need the talent to do. And the new addition to our list of banned Wi-Fi words, data rate. Okay, we can still talk about data rates, but we got to use the right context and think about, is it actually more meaningful just to talk about MCS instead? So there you have it. And I think with that, we can jump into some Q&A.
Sweet deal.
Looks like there's been some good chat. And I'm going to pick out a question here real quick. First question from Romac. And question is, even though I have mostly AX devices, I never see my stations or APs reporting link rates that would indicate those small RUs. Why is that? Does that mean my AP is not scheduling RU-based MU transmissions? And let me just transition back to our video. Yeah, I think that is. I think that's the case. The scheduler, in order to decide to use OFDMA, there has to be, buffered packets, and there has to be enough congestion for that to make sense. So like I mentioned, 802.11ax will do single user operation and multi-user operation. And I did a actually previous webinar earlier this year on, I think I called it Unlocking OFDMA, where I talk about the decision-making process behind that. So often APs will decide we'll stick with bread and butter single user operation, and that's why you're probably just seeing those rates for now. And maybe a couple more here. I see Eric. He is emerging from the catacombs. Andrew says, is OFDMA something we should disable or move away from in certain situations? That's a good question, Andrew. I I know there's been some disappointment about how we were marketed OFDMA when 802.11ax was in development and first released, and how it's, you know, the what we've actually gotten from it. But I would say no, unless there's a known bug, you know, with an AP vendor's implementation that you think might be causing a problem for you. I don't see a reason to disable it entirely. But just curious, once again, welcome anyone in the chat to answer that too. And how about one more question here from Nick? And I think we can transition after this one, Heather. Nick says, is it good practice to disable the higher data rates /MCS values? I see. You're already thinking data rate MCS. I like that. To prevent overly ambitious client drivers from wasting time and trying them when it's not necessary for the type of application in use. In other words, is it a good way to achieve more reliable and efficient use of airtime? That's a really good question, Nick. One of the things that certainly that's something that we saw in design years ago with when we first got OFDM rates, and thinking about like a warehouse application with a barcode scanner, and it needs very, very little throughput. There's not many other stations there, and allowing it to kind of rate shift up and down would result actually in some unreliability. The retries would get higher, and it would, you know, those devices might struggle to settle on a data rate. When if you just disabled those top end OFDM rates, then it could only shift so high, and it would just stay there, be nice and stable, and you'd still meet all your application requirements. So I don't see that much anymore. I think the 11AC and 11AX clients tend to have pretty good rate shifting algorithms, and the high density designs that we're typically doing today can support the SNR necessary for those. So you know, we did an interesting webinar with Keith maybe a month ago, looking at MCS values that our clients are using, that are running Mobileye, and a lot of those when they're connected to 11AC APs, they're sitting on MCS 8 and 9 an awful lot of the time. So I'd say no, leave those rates there just so they're available for clients that can take advantage of them. But, you know, again, there could be very specific circumstances that might suggest not to do that. So good question. Thanks, Nick. All right.
Great. Time to bring Eric out of the darkness. And there he is, right on time. Welcome, Eric.
My pleasure to be here. Yes, I've been listening, lurking, and I am now here. Thank you, Jim. That was totally awesome. We're going to talk a little bit about how Sapphire Eye can help us unpack all of this. That's right. It's time for 7 Minutes with 7 Signal, where we take a little feature inside 7 Signal, unpack it, show you how it can have huge value in relation to the topic today. So let's do a little screen share, shall we? Say that 5 times fast. You can't do it.
I was about to say, that's a heck of a tongue twister there.
All right. If you can see my screen, give me the thumbs up. All right. Okay, so we're inside Sapphire Eye, and we do have this legacy report called data rates. No, we're making the transition. We're making the transition.
We are.
All right, so we've got the data rates report, and as you can see here in the settings, we are measuring these rates. Sapphire Eye is like a client, right? So we want to see what rates these clients called Sapphire Eyes are achieving based upon the conditions. Also, we're able to sniff or pluck out of the air the data rates of all of the devices that are in the area, because remember, a Sapphire Eye is also a bit of a sniffer, and it's doing these little packet captures every few minutes or so. And you can see based upon OUI that we are gathering up Apple devices, and this is the copy machine that we have, the Xerox. That's a wireless printer, of course. Intel, that's going to be your Dell and Lenovo laptops. So we've got all of those in there as well. So the first report that I'm going to run is end user data rates, and we're going to look at data rates right here. So let's do that. And actually, I've already run the report, and this is what we have. All right, let me zoom in. Boy, is it confusing. Goodness gracious. I've got, these are the OUIs of all, or the MAC addresses of the clients that are connected to this corporate access point. And you can see all of this detail. My goodness, we can see the PHY, AC, and we've got the MCS in here, 5, channel width, so it's W40. And then we've got the guard interval, look at that, 800 nanoseconds. And then we see how many spatial streams are in use in order to achieve that. And you can see going all the way up here, these are like our MacBook Pros in the office, and then, these are our Windows machines down here, right? But using the 3 spatial streams. Although I think the MacBook Pro, the newest MacBook Pro that came out, correct me if I'm wrong, Jim, it's a 2x2.
2x2. Even the MacBook Pro Ultra that you can spec into the tens of thousands of dollars, 2 spatial streams.
Unbelievable. I don't know, man. I think they're probably doing that for battery consumption. I don't know. They're going green. I can't explain it. Nevertheless, lots of detail here. This can be a bit confusing when I'm trying to answer the question of link quality. That's what we learned about today, isn't it? So I'm going to rerun my report. All right, but first, before I do that, I do want to go down here and show you. I had a 2.4 one here. Okay, I did want to show you this. These are the data rates that are being reported on for 2.4. This Linksys AP is a 6E, 6 gigahertz access point that we bought, at the store. It's running 2, it's running 5, it's running 6. I just wanted to show you guys how weak this is, that it's actually pre-configured out of the box on 2.4 to use these legacy data rates. You see that? It's not like in an enterprise environment where, you can toggle those off and go no lower than 12. And we all know, guys, if a client can go slow, it will. Okay, they love to go slow. It's like couch potato, right? Feels good to go slow. So let's go back up to the top, and let's run the MCS report. And let's take a look at that. So let's go to report. Oh my gosh, look how simple that became. 0 through 9. And now I can really truly see, based upon the magic number of 4 and below, what the environment or quality is truly like. And let's scroll down a little bit more. Again, wow, look at this client right here. So whatever client this is, and I can mouse over it, get its MAC address, and if that's in my controller, I can look it up and see exactly who it is spending 100% of its time at an MCS of 2. Yowzer, that is bad news, Jim. Bad news. And then we even have some at 0. Okay. And then connected to this access point here, same thing. You can see the link quality going all the way down, all the way down. And then when we get to 2.4, and this is why I wanted to show it to you, is we see the MCS go all the way up to 15, because with N, right, it doesn't stop at 11. We can go up even higher. So that causes a little bit more confusion, perhaps, when I'm trying to normalize this situation. Let's go back up to the top. And the last thing I'm going to show you is 7 MCS. And 7 MCS basically normalizes it, whether it's Mac, Windows, Android, it doesn't matter. We normalize the scale so that no matter what you're on, what you're using, it's going to be just a plain old 0 to 11 score. Okay. And for the instances where it gets a little bit hard to tell, you know, between 6 and 7, then we just go with 6.5. And the reason why it's not a big deal is because, once again, we're really on the lookout for values below 5. That's the key. That's what we learned today. So let's run this report. And away we go. Let's scroll down, and there you have it. There you have it. 7 MCS. Okay. So really looking good here. The majority of the devices in the environment are spending the bulk of their time at 5 and above, and we've got a little bit of conditions here to worry about. And remember, I'm looking at a whole week. If you look up at the top, it's a whole week. And so there may have been some instances during the week where the RF conditions got really out of hand. And again, we go down. It's really simple, really easy to use. And this is where 7 Signal is heading. Moving forward, we want to use the MCS almost like a Wi-Fi quality score in order to not only evaluate our Wi-Fi environment and the health and wellness of the conditions, but also of our devices as well, using the reporting tool that I just demonstrated. So that's it, guys. That's what I have for you today. Very excited to be here and talk about this new stuff. MCS is the way to go. I won't use that dirty, bad word anymore. I'm sorry, Jim. And I apologize if I offended you or anybody else in our audience today. So with that said, I just want to remind you all that you and me, we can't see or hear Wi-Fi, but 7 Signal can. Thanks, everybody. Back to you, Heather.
Awesome. Wonderful. Thank you so much, Eric. Thank you, Jim. Thanks to all of you for staying engaged. Really great session today. So you know where we'll be. Same time, same place next week, and we will see you there. Bye-bye.
Thanks, everybody.
Take care.